Welcome back to the Explainer. So last time, we walked through the whole chain that gets a P&ID onto the table, right? Moving from process simulations to heat and material balances and down through process flow diagrams. Well, today, we're tackling what happens next. This is that critical, high-stakes transition. For anyone who's ever looked at one of those massive offshore platforms or a sprawling petrochemical plant and just wondered, how on earth do we go from a digital concept to thousands of tons of welded steel? Well, this is exactly where that magic, and honestly, that risk, happens. We're going to focus on how that same P&ID, the piping and instrumentation diagram, actually dictates the heartbeat of a construction yard through something called the Workfront curve.
But look, before we get deep into the mechanics of drawings and curves, I really want to anchor the stakes for you right out of the gate. $12 million. Just picture it. Your massive fabrication yard, totally packed with cranes, scaffolding, highly skilled crews, and it just sits idle for 12 days. Why? Because they're waiting on IFC, Issue for Construction Piping Isometrics. What does that exact delay cost the project? $12 million. And here's the truly terrifying part. That $12 million is just the baseline burn rate. We're talking before liquidated damages even hit, before extended vessel charter costs pile up, and way before the massive reputational hit your company takes. Every single concept we're covering in this explainer today exists to protect those 12 days and that $12 million.
To really grasp this, we've got to recognize that there are two totally distinct universes in any major project. First, you've got the paper world. This is the realm of process simulations, pristine P&IDs, and 3D CAD models. It's clean, it's digital, and it's highly theoretical. And then there's the steel world. This is the fabrication yard, the welders, the sparks, heavy lift cranes, harsh weather, the whole shebang. Your entire job as a project manager, or an engineer for that matter, is essentially a high-stakes baton pass. Your main function is making sure the paper world arrives at the steel world early enough and correct enough to actually be built. You literally have to hand off that baton at full speed.
Now here's what most people outside of core engineering never quite understand. A single P&ID isn't just drawn once and handed over. It evolves. That exact same drawing actually gets issued 4 separate times, and it gains massive technical and legal weight at each stage. Let's walk the chain. Step 1 is IFR, Issue for Review. This is just the initial process design, sent out for internal and client comment. Step 2 is IFD, Issue for Design. Now the critical details like process line diameters are locked in, and this becomes the basis for every other discipline to kick off their detailed work. Then, Step 3 is the HAZOP, the Hazard and Operability Review. This is where a multidiscipline team systematically hunts down any dangerous process deviations. Finally, we reach Step 4, IFC, Issue for Construction. This is the only stamp that actually lets someone cut steel.
And what's really interesting about that final step is just how uncompromising it is. An IFC stamp isn't just some label. It has a hard, unforgiving definition. To legitimately stamp a drawing IFC, 3 absolute conditions must be met. First, every single action generated from that HAZOP review, it must be completely closed out, no exceptions. Second, all finalized vendor data, meaning the exact footprints, weights, and nozzle orientations of purchased equipment, has to be incorporated into the model. And third, the PSV, the pressure safety valve sizing, must be absolutely confirmed. These aren't just guidelines, folks. These are mandatory binary gates.
So what happens if you miss even one of those 3 mandatory conditions? Let's say a piece of vendor data is still pending, or a HAZOP action was left open, but you go ahead and issue that drawing to the yard anyway just to meet some scheduled date. Well, what you've issued is not an IFC drawing. As project veterans know all too well, what you've actually issued is a rework order with an optimistic stamp on it. You are basically guaranteeing that a welder in the steel world is going to build something that will have to be cut out and rebuilt 2 years later at 100 times the cost. You just cannot cheat the IFC criteria.
Okay, so how do we track if we're actually feeding the yard with legitimate drawings? We use the engineering workfront curve. Imagine you're looking at a tall blue bar representing the cumulative construction content on legitimately issued drawings. Let's say cubic meters of concrete we've fully engineered. Next to it, there's a shorter orange bar, and that represents what the site has actually completed. The physical shaded gap between those 2 lines is your workfront. It is literally the yard's oxygen supply. If that gap shrinks, your yard is suffocating. To keep that yard breathing, you absolutely have to obey a strict rule of thumb, the 3-week production cycle gap. This is the absolute minimum buffer required between the moment a construction drawing is issued and the moment the site actually completes that physical work. Why 3 weeks? Well, because the yard needs time.
They need time to receive the drawing, plan the work, pull the materials from the warehouse, stage the scaffolding, assign the crews, and actually execute the job safely. Squeeze that gap below 3 weeks and total chaos ensues. Think of it exactly like following a massive transport truck on a busy motorway. If you leave a 3-second gap between your front bumper and that truck, you drive smoothly, right? You can anticipate changes, you maintain a steady speed, and everybody stays safe. But if you tailgated a close 1-second gap, you're constantly braking, then accelerating, then braking again. You don't arrive at your destination any faster. All you do is burn excess fuel, wreck your gearbox, and vastly increase your risk of a crash. Squeezing that 3-week engineering buffer does the exact same thing to a fabrication yard. You don't get a faster yard, you just get stop-start fabrication, idle welders, and a massive productivity collapse that you absolutely cannot buy your way out of.
Let's test this logic with a real-world scenario. Honestly, this is what separates average coordinators from elite project managers. Imagine you're sitting in a monthly project review. The engineering manager proudly stands up and reports that detailed engineering is 100% complete. Everyone claps. But then you look at the Workfront curve, and the curve is entirely flat. The line for new drawings reaching the yard has totally stalled. So let me ask you, is that project healthy? Take a second to really think about what that means for the guys out in the steel world.
The answer is a resounding, definitive no. That project is in grave danger. Here is the hard truth that catches so many teams out. Percentage complete tells you absolutely nothing if the yard doesn't have the specific sequence of drawings they need next. If engineering is churning out drawings for the top deck of a module, but the yard is still waiting on the structural drawings for the base deck, well, that 100% completion metric is a total illusion. Sequence always beats percentage complete. You have to feed the yard in the order they build.
Which leads us to this final, provocative thought to take back to your own projects. Do you have a full document register and an empty yard? It's incredibly easy to fall into the psychological trap of celebrating a high volume of issued documents. But if those documents aren't the exact IFC drawings the yard needs to execute their sequence today, your welders are still standing idle and that $12 million clock is still ticking. Always read the Workfront curve, never just the completion percentage alone. You have to protect that physical fabrication sequence at all costs. But remember, flat drawings only take you so far. When you're fighting for space and buoyancy offshore, that fight actually happens inside a 3D model. Join me next time as we dive into 30, 60, and 90% model maturity reviews. Thanks for joining me for this explainer, and I'll see you in the next one.